Welcome to today's lesson. Now, in today's lesson, what we'll be talking about is dimensions, all right? Now, in dimensions, we are basically trying to represent the quantities in meters, all right? Okay? Now, the quantities, we know then mass, we know there was length, we know time, okay? You can guess this is usually fundamental what? Quantities, all right? Fundamental quantities. Now, in each of the various quantities we talk about, we want to actually check their dimensions. Okay? So when we talk about dimension, we are just saying a linear representation of each quantity. So for example, if I am say speed, okay? And speed is equals distance over time, right? Now, if you look at this, we said from the previous lesson, the first lesson, that distance is also length, right? If I'm moving along a length, that's called distance, okay? So I can say this is length over what? Over time, okay? Now, we go back to what we have here. Time is represented with a T, and length is represented with N. Okay, so instead of using L, so it means speed dimension is just L over what? C. Okay, now we know this can be written as L multiply 1 by what? T. And in mathematics, this is what we call a reciprocal. That's like say L times C raised to the power minus 1. And that should be L C to the power minus 1. Now, this is the dimension of speed. This is the dimension of what? Of speed. Again, we could also look for acceleration. Let's see acceleration now. We know acceleration is related to what? Over time, right? So we can start breaking down everything that's here. So this should give me velocity is the same thing as distance, which is our length, over time, then divided by this time that is here already. So when I look at this thing, I'll just go straight to the point. Distance is the same thing as length over time. This the initial sign, I could say this is time. So if I change what is there, it should give me length times 1 over time over time. Okay? So moving forward, this would just be L over T raised to power 2, right? Because I know that my time is T. This time here is T, so T multiplied as a T to the power 3. And again, if we follow through this process, you see that when you have something as this L times 1 over T raised to power 2, whenever you have 1 over any letter raised to n power, what you just do is, this for this T to go or for the any letter to go, you just use L and this L T, and this power n comes to negative 1. That's also right. Okay? That's just how you get, so that's how you get in dimension. We could actually go further. There are other things. One, other quantities that we can actually check their dimension. That's so many now. I'll be putting some of those quantities in the description of this video, so that you take them and you work on them also, right? So if I consider force now, is equals M what? A, right? So the dimension for force, or the mass, that is, if you don't forget, remember, we said the representation of mass is N, okay? Then for acceleration, we already did acceleration, right? So I can just introduce it as T raised to power minus 2. So this gives me my what? my dimension for this particular force. So we could go on and on like this, because every quantity, either fundamental or derived, has a dimension. They all have a dimension. So we could get the dimension for every quantity when coming back to it. So I think work done is force rate times distance. Okay, so you see that we can also do something also. So this could be like force. Distance is what? Length, L. So if I bring it further again, I could say this is N balance L series on minus 2 times. This is my force. Then my distance is L. Okay? Now from the equation here, you can see that L has to multiply L plus. That's the same letters. So this could be N L times L. That would be L squared series by minus 2. This is the dimension of work done, because work done is just the force applied times the distance traveled. Okay, so you see here that you can easily get dimensions of any physical quantity. Now, for this video, what we just want to improve, and isn't this what we need to do, is just introduce the concept. So if you don't understand what I did just now, you can go back, rewind the video, go back and just listen to the video slowly, so you can get a real idea of everything and see it. Okay? Just to recap, we said dimension is a representation of the physical quantities with the letters, right? Then we said the fundamental quantities, which is mass, length, time. Mass is represented with M, length L, time T. Okay? So since we know that we can represent fundamental quantities with this, definitely, if I bring out any formula to get either acceleration, velocity, and mass, I can put a dimension to them, because for this acceleration is velocity over time. Okay? Velocity itself is distance over time. And we know that distance is also length. That's why we used length here, divided by time, divided by this time at the bottom here. Okay, so we just change the division sign to division sign. Time goes down, 1 comes to the top. So time times time plus T. I just need series parts. Okay? Length L and top. So what I did here was to break it into two parts so that you see clearly how there will be a raised to power minus 2. So this is like a reciprocal. To rewrite it, to mean this is, you just take the serious part to the top, the other negative sign to it. That's just how to convert it. Okay? So we can keep on going like this. Then we can also go for energy. The formula, break it down to the basic units or the fundamental units. Then we can get the dimensions. And most times, in most cases, or all the time, let me know, you always see no matter how complex the concept is, either it is energy or either it is calorie or in calorie metal, you will definitely fall back to this with LLC. There might be some dimension, like for work done, and there's MLC. For force, there's MLC, but for acceleration, there's LC. So whichever one, but there's a dimension to every physical work in it. Okay? So what I want you to do for me now is, if this video is actually valuable to you, finally learning lots from this video, share it with friends. Okay? This video should not just be for you alone. Like I said in my first video, the purpose for these lessons or the purpose for this platform is to actually help students to grow and to achieve what they plan on achieving as pertaining to achieve. All right? So I know you must have liked the video. So what person can see it, then share